Thank you so much. Thanks for the introduction. I will do another quick one. So who am I? My name is Artem. I currently live and work in Sydney in Australia. It's been a long flight for me. I'm still a little bit jet-lagged. It's hard to believe, but I'm almost 20 years in industry. I'm at the moment not that active open source contributors. I've been contributing previously to a few big repos like Jenkins, Selenium WebDriver, Phantom.js. I have my own open source pet project, code coverage plugin for Bitbucket DC. I'm also father of 3 kids who occupies most of my free time. But when I have a free minute, I also do surfing, I do yoga, and I'm racing driver and racing official in Australia. But all of that is not the reason why I'm here. The reason I'm here is because for the last 8 years, I've been working at Atlassian on Atlassian cloud platform as a software engineer. And I have a lot to share with you about how we deal with microservices at Atlassian. Why are you here? Are you working on monolith? Raise your hand. Come on. There should be more of you. Yeah, good. Considering moving to microservices? Yeah, don't do this. Are you developing microservices? All right. Enjoy it? Not much? Considering moving to monolith? No? Are you stuck in the middle? Macroservices, someone called it? Or distributed monolith? Yeah, worst of that, both. OK, so the title of my talk today is PaaS, addressing microservices drawbacks at scale. And to get to the bottom of it, I would like to decompose my title, and we will talk about each part of it in a sequence. But before I start, I need an assistant from who wants to assist? All right, you. I've seen you. You raised your hand. Thank you. May I ask you to count how many times I will reference Docker? You can stay where you are. Just keep count on how many times I will say Docker in my presentation. All right? Let's try it out. Docker. 1? No, it's 3. It's 3 already. OK, let's get started. I want to start with talking about microservices and their drawbacks and briefly touch the scale. But to actually get to microservice, we need to start a little bit early. We need to start with a monolith and why we ended up here. So in early 2000s, I guess, when all the people started to build web services instead of applications which they ship on compact disk to customers and install on computers, right? Our industry blow up with the web services. Everyone started to build web services. And because changes take time, we just continue to do what we did before, right? We build a single application. We called it monolith later on. And as we start to, as applications start to get bigger, we started to realize there are many challenges with managing these applications this big. I broke it down into 3 main categories, right? First is development. And that's what developers are mostly complaining about when working on monolith. That you have a complex and big code base. It's hard to get the context of what is happening. There's problems with consistency because new frameworks and new tools bring out all the time. And you need to do these migrations. And it's hard because everyone hates the migrations. There are testing challenges, because when you have a big applications, you cannot easily run it on your local machine. You need a development environment maybe staging environment, which is, again, a big problem because the application is big, the infrastructure is complex, so how you deal with it. And all of that creates a maintenance overhead on your, for your service. Second is the build time, right? OK, you've done this development. Now you want to build and deploy it. But because it's a big, complex application, again, you have a big release, which is very risky to roll out in production. You have complex and flaky pipelines because you need to run integration tests. Because you remember we had issues with local testing. You cannot easily run it locally. So you need to do a lot of integration and manual testing once you actually made the change. And finally, once it gets to production, it's a big issue because it's a single point of failure from multiple perspectives, right? Security, if your application is compromised, you get a key to everything suddenly. Reliability, if single component misbehaving in your system, it affects the whole application again. It could bring it down easily. Cost attribution, we have a great talk previously by Ricciardo about the cost. So in case of monolith, it's very hard to actually track where the cost is going, like which feature is consuming cost and which feature is bringing you money. So, and then came Agile to the rescue. And part of the Agile manifesto was saying, all right, we know what to do. OK, we need to ship more frequently. We need to change from quarterly releases, from monthly releases to 2 weeks, and then it all goes to extreme programming and CI/CD. But again, changes not happening overnight. So instead, we get this. All right, we cut the scope. Right, we cannot. It's not ready yet because we plan to do it in 3 months. We need to release in 2 weeks. All right, let's release this. And then DevOps. Just a few years later, it's like mid-2000, when DevOps start to emerge, and the DevOps engineers who manage their runtime came to talk to software developers, saying, "Hey, it's not all right. We don't want to release these big changes, right? Because there are so many changes. It's so risky to deploy it." Right? And you had not tested it properly yet because you don't have a proper test environment. And I say, let's shift all of this to your dev cycle. Let's try to address it early. But you cannot, because it's a complex application. So developers say, all right, we will start decomposing the monolith. Right? We will slice and dice it. And it looks like on a picture. It's very lovely, right? You split it in twice, you have 2 very similar parts, but it's not how it is in real life. Because at the moment you split it down, you put it in 2 different repos, it starts to live its own life. The one team brings their own tools, another team, they hate the framework you've been using before. There's a new hiree who wants to write in Rust or Golang, and it starts to diverge. And it starts to, the more microservices you have, the more diverse infrastructure you're creating. So let's take a step back and actually see if microservices addressed all the problems we have with a monolith. So in development, first complaint was complexity. Actually, it never gone anywhere. It's just shifted right. Because previously, you have all this complexity inside your code base. Now it's distributed across multiple services. And it brings new challenges, actually. Consistency? No, we hadn't addressed consistency. In fact, it's even less consistency. Because you now have different frameworks, different languages, different build tools, everything different. Testing? Yes, it's better to test now because microservice you can run on your local machine. It's easy to spin up the development environments, but at the same time, it introduced new testing challenges, like the whole chaos testing, contract testing emerged because they need to address these microservices problems. And maintenance overhead. Previously, you have to maintain a single code base. You need to update your library. You do it once. Now you do it 100 times, 1,000 times, depending on how many microservices you have. Build and deploy. We used to have a slow, heavy builds. Now it's fast and lightweight. Big and frequent releases changes to small and frequent. Looks good, right, so far? And we have a complex and flaky pipelines. Now we have a very simple pipelines because services are small. But the asterisk here is that they're all different. Each team is using their own tooling, right? So, and speaking of runtime, we switch from a single point of failure to a distributed point of failure. Yes, we contain the blast radius for your security problems, for your reliability, for observability. But at the same time, we had a great talk about the security vulns previously in the morning. Again, in a monolith, you can address it once. With microservices, you need to fix the same vulnerability potentially, like hundreds, 1,000 times for each microservice individually. And it all like scales with the scale of your microservices. How big of the scale we are talking about? To bring you some context, at Atlassian, we are currently running around 3,000 microservices in production. Looks a little bit high, right? It's only probably half of it, because we have another 3,000 in non-production, like in def and staging. We are doing, on average, 2,700 deploys in a week. So if you exclude the weekend, that means, on average, service deployed to production 1.5 times a day. So we adopt CI/CD at scale, like services deploying all the time. And we are running in 11 production regions. So you can imagine the scale of the problems with the microservices I outlined before at Atlassian. So how we deal with this? There is a statement which sometimes referred as a fundamental theorem of software engineering, saying we can solve anything with adding another layer of abstraction. And this is exactly what platform is. So platform is abstraction layer on top of your infrastructure. It could be cloud infrastructure. It could be your DC infrastructure. But the main point is we abstracting this away from our developers. So let's have a look at how it looks at Atlassian. And I will, again, go through the same sections, the development, the build, and the runtime. So we'll start with development. Our contract with our developers is very simple. You give us Docker image. Are you counting? Yes. Thank you. You give us Docker image. And you give us a YAML file, which is describing what you want, right? And the YAML file is very simple. There's two main sections. There's a section on top which is describing your service, which is basically like, what image do you want, port you expose, yada, yada. And then resources, like which cloud resources you want to use. It could be like a queue, it could be RDS, like Kinesis, Kafka Streams, whatever is available. And then we will convert it to a comprehensive infrastructure. You see that, like in this YAML file, there's nothing about, like, no details about what is running underneath. And what you get is there will be around 53 records created for your service. It will be pointing to a load balancer. Load balancer, in terms, will be pointing to your auto-scaling group, to scaling your traffic, to serve your traffic. We'll provision all the resources you requested, like RDS, it could be managed DB, DynamoDB, SQS, whatever. We'll create a cloud identity, IAM role in case of AWS, so you can actually access all these resources. We will inject environment variables, the secrets, everything you need. in your application. We will set up a login pipeline, a metrics pipeline. So the only thing you have to worry about, it's your application code. How we get from the YAML file to this infrastructure? Local dev. Local dev is essentially looking the same, right? You're just replacing the compute running in the cloud with your local machine, and then you can access the same resources in the cloud, or you can go as far as like running everything locally. There are Docker images available for all the cloud resources, for caches, databases, queues. You can replace all of this and have the using the same YAML file. You just need to say that you're running it locally, and we will set it up. So how we get from the YAML file to this cloud infrastructure? There's a few ways, but the main point here is that we have API layer in front of our PaaS. And the same API layer is used by all the integrations. So we have a CLI at the bottom. That's the main user interface that our developers are interacting. So they're basically saying, hey, deploy my service. This is a YAML file. CLI is also used inside Bitbucket pipeline. So in your branch, you can do the same. You can deploy your service in your branch build. There's a Spinnaker integration. I will talk about it shortly. Another major point is all of this is also integrated with Atlassian Compass. So if you are not familiar, it's a relatively new Atlassian product, which give you like a central place when you can store all the metadata about all the services, all the owners, which is very handy when you manage service at scale. All right, so that was the development part. Now we come into build and deploy. As I mentioned earlier, we are using Spinnaker as a main orchestrator for like a build and deploy. Spinnaker is an open source tooling. I couldn't say I like it because UX is very confusing. It's very confusing, but it does the job. The main point is like you set it up once and you forget, because we have a managed pipeline. You just saying, I want to deploy my service in this environment, and that's about it. Spinnaker, this managed pipeline will manage everything else. So we have progressive rollouts, which means by default, when you deploy a new application, a new application stack will be created. Traffic will be gradually switched to a new stack. We will monitor all the metrics and detect anomalies. And if anomalies happen, we will switch it back automatically. And when you need to deploy in a multiple region, as I said, we run across 11 regions. We have services who run in all 11 regions. To contain the blast radius, the same like default pipeline can deploy in one production region, soak for time, look for the metrics, deploy it to another two, and so on and so on. And like in general, developers don't care about this part at all. So the moment you merge the code, everything else will be automatically deployed. So that's a main workflow. The most interesting part is actually runtime. And it starts with security, because security always comes first. So I will talk about the secure infrastructure and secure communication. There's a lot of more to cover, but we have only limited time. So get back to our picture when this infrastructure for a typical service. I want to highlight a few things that we automatically configure, right? So it starts with a secure host, which means, as you've seen in this YAML file, developers don't control like which OS they are running, which machine image they are running. It's all automatically provisioned by the platform and configured in a secure way, which means even like everything is running in Docker, and even the Docker, if the Docker container is escaped, like everything is contained within the EC2 host. They cannot actually do anything. We provision all the secrets you need to access your, say, RDS. Again, say it's stored encrypted, it's downloaded when the instance is starting up, it's then wiped out. So no one can access it. We automatically install like runtime scanners on your host, etc., etc. Second part is secure network. And again, a few points here. So we have security groups, which is a way you configure the file network, ACL, and firewalls in AWS. And security groups are configured in a way that your application can only access resources that belongs to your application. So, for example, RDS on the bottom here. Another service cannot access your RDS because the security group configured in this way. Same with the load balancer. So your autoscaling group and your nodes running your compute can only be accessed from load balancers. They cannot be directly accessed from the internet. Load balancer itself is sitting behind the managed edge. So actual internet traffic is landing first in a cloud front, then it's hitting the managed edge, where the centralized web application firewall, DDoS protection, all this happening, and only after that it's routing to a load balancer, which is internal. And secure resources, like everything is configured, again, is in a very secure way. Like if it's a managed service, say it's a queue or it's a DynamoDB, like things like encryption at rest, encryption in transit, it's all enforced. The developers don't have control over this infrastructure. IAM role, again, it's configured in a least privilege way. So you can only access the resources that belong to your service, and that's it. But it's all like about the single service. So what's happening when two services need to talk to each other? And in communications, there's two aspects, right? There's AUSN and AUSZ. So for AUSN, we are widely using ASAP, which is Atlassian Service Authentication Protocol. It's actually it's open source spec. It's based on JWT. JSON Web Token Standard. It's providing you the way to authenticate using asymmetric encryption. So you have a private and public key pair. And what platform does, it will automatically provision it for your service. It will automatically rotate it. So with each new deployment, you are getting the new private key, which is securely injected in your environments that you can use. And then there's to actually remove the burden from our service developers to implement this ASAP protocol in each microservice. We have a Docker sidecar. Sidecar is like a Docker container which is running alongside your application, which can do some workloads. So we have service layer authentication implemented as a sidecar, and it's automatically running for your service, so you don't need to worry about authentication at all. Authorization, very similar story. We are using tool calling policy control, or POCO. It's our internal Atlassian implementation of open policy agent, which is an open source general purpose like decision-making engine. It looks like this. Again, it's a YAML file where you can say, I allow or I deny access to a specific endpoints for the specific issuers or principals. You can say it's open for everyone. For example, if it's a Swagger spec, you want to open up for everyone to consume. And it's very powerful in a way that because it's all standardized, we can actually scan all our services, identify the bad practices when, say, access is too open, and we can work with the service owners to address these security issues. It wasn't implemented as Docker container from the very beginning. So we started with a library for ASAP, but we realized very soon that it's not going to scale because we need to support like a Java library, Python library, Golang library, Node.js library, whatever else people are writing on. So we replace it with a Docker sidecar. As soon as ASAP get adopted across all the services, we also introduce the authorization layer inside the same Docker sidecar. Quickly on reliability, or when you run in production, again, We are providing you with a safe default, so it's you already seen there's a load balancer, there's an auto-scaling group, so we are taking care of it. We are not allowing you to run on a single instance, because in a cloud, you cannot assume that your instance will survive. We provided tooling for automated war games, like terminating chaos testing, terminating instances randomly. It's happening all the time. We're also failing over caches between AZs. We're failing over RDSs across the whole fleet all the time. It's just happening there. And zero downtime upgrades, already mentioned, with a Spinnaker and progressive fallout. We are taking care of it. Observability, a big topic, which probably deserves its own session. But again, quickly, we have standard metrics and standard metrics pipeline. It's another Docker sidecar running on a host. Are you counting? Great. Which will collect host level metrics. It will collect container level metrics. You can emit your own application metrics. It all will be aggregated on a host, sent to a central location. Very similar to the logging. We have a Docker login sidecar. Are you counting? OK. Very similar. It's aggregating logs on a host, and it's shipping it to a central location so you can access it. We will set up the default alarms, which you can tweak if you need to, for your EC2 health, your load balancer, all the resources, like how many messages you have in a queue, et cetera, et cetera. So how all of this is helping to address the issues with microservices, right? That's the main questions we are trying to answer. Let's have a look. So we have problems with complexity shifted right into runtime. Had we addressed it with a platform? Probably not. You still have to deal with that. There is no way. Less consistency? Yes, partially. It's still diverse at tech stack, but at least we have a standard UX. It's a consistent dev loop because everything is standardized as a Docker. So it's a minimal unit. So it's quite easy actually to move between teams because even though the tech stack is different, the whole dev loop is more or less the same. New testing challenges. Yes, we have some tools to address it, like automated war games. But again, it's something you need to work with. And maintenance overhead to manage multiple repositories. We not fully addressed it, but at least we removed the whole infrastructure layer from the developers. So infrastructure is exactly the same. Like you can take any two services, underlying infrastructure is very much the same. Building and pipelines. I would say this is part which is very much addressed by the platform. And even though I had the Spinnaker UI, it gives all the default pipelines and defaults we set up, actually addressing this diversity in the build tools, because everything is deployed exactly in the same way, same and safe way. And runtime. It's still distributed point of failure, right? So don't get me wrong. You still have issues with security, reliability, cost attribution. We have a great talk about the cost from Ricardo earlier. Observability. But again, because it's all now standardized, it's much easier to work with that. Like when security are coming and saying, hey, there's a new critical vuln, they have a central place where I can reach out to service owners, identify which services are affected, and then work with them. Again, observability, logs, and metrics, it's all in central location, which means if you're debugging an incident, for example, in production, you know exactly where you need to go to find out what is happening. All right, so Before I wrap it up, a few points. First is there's nothing wrong with monolith. As long as you understand what are the trade-offs and what exactly are you trading off. It is fine, like it's just a trade-off. Microservices is also a trade-off. Yes, they address some of the problems of the monolith, but they also bring in new challenges. And you need to account for it when you decided to go with microservices. Last but not least is that platform can help you to address some of the microservices problems, but not all of them. Like you've seen, like we went through this list. There are many areas which we had not yet addressed. And it's a lot of work, right? Platform itself is you need to build it, you need to run it, you need to maintain it. It's not free. So remember at the beginning we were saying that we can solve everything by introducing another layer of abstraction. There's a second part of this statement, which is saying, except for too many layers of abstractions. And before I finally wrap it up, how many times did I mention Docker? 17, all right. And you probably know if someone mentions Docker so many times in presentation, you can guess where it's all going, right? Yeah, we are currently moving to Kubernetes as a main orchestration engine. And I hope like next year I'll be presenting here about our journey to Kubernetes. And that's all I have for today. Thank you.